Here we go. So welcome to Transport Phenomena. Once again, this class is named 381M for whatever reason. And I'm just going to briefly introduce myself again. I respond to a lot of things. You can write anything remotely similar to my name and I will still respond to it. But please just learn to say Masha as opposed to Masa, which is what's written. Masa is a whole lot of things. It's, for instance, masa farina. You can make tortillas from it. I'm not Masa in my language, which is Croatian. I come from Croatia. Masa means mass. I don't like being called mass. As heavy as they can be sometimes. So please just learn Masha, and whatever you make out of the last name, I don't mind. It is Prodanovic, but it's complicated to remember, so I respond to Dr. P as well. So I did my bachelor's at the University of Zagreb in Croatia, and I did my master's and PhD in New York State University of New York at Stony Brook. And if you want to find out more about either my CV or research or whatever else you might want to know, it's on my website. I respond best to email. It's masha@utexas.edu. You can notice that I stick in an H that actually doesn't appear in my name, simply that people say my name correctly. So, and my office is on 4th floor. My office phone is listed, but I rarely respond to it because I'm either in a meeting or not in my office. Email is actually always the fastest. Or stopping by. So I have listed office hours as Wednesday, Friday, 3 to 4, or by appointment. So feel free to email and see if you can stop by. I apologize in advance if I can't make it. I do have 10 graduate students and 2 postdocs that I'm meeting regularly. So, and 2 classes that I teach this semester. So likelihood of just dropping by and me being available is a little iffy. But if it's a couple of minutes, I can typically respond to it. Our teaching assistant is Rahul. Rahul, please identify himself. So Rahul Verma has done this course. He's also done qualifying exams. He's been around the block in this department, so he can give you any information you might need about the program in general, as well as this course. I don't know, what do you respond best to? Emails, texts, knocking on the door?
Emails are good.
Emails are good. So notice that I'm not listing his office as a location because there's also 2 other people in that office. So, and it's a small office, so it's not appropriate for office hours most often. So that's why I email him first before stopping by, simply not to disturb other students in that office because it is a kind of a tiny space. So office hours will be in student lounge on the 3rd floor. So, and so far we have listed them as Tuesday, Thursday, 2 to 3:30. If I'm not mistaken, most of you should have courses only Monday, Wednesday, Friday. Is that correct? No, that's not correct. Is this colliding with any of your other coursework if your courses are Tuesday, Thursday?
I think so.
You don't think so? Okay. So check and let me know. So this can be moved. Same with does anybody have a class Monday, Wednesday, Friday, 3 to 4? Okay, so that should be fine. Monday at 3 o'clock is the graduate seminar. So I do highly recommend, however busy you are, make an effort to visit seminars. Seminars are important for various reasons. One is, of course, the research might be relevant to you. But even if research is not relevant to you, graduate seminars should be approachable enough, whatever your topic is, to all of the graduate students in the department. So you will learn about what's going on in petroleum engineering in general. It's good to know also for your future job or for your future research information. So just keep that. I know it gets really difficult during semester to actually attend those, and it's sometimes you have priorities like, oh, homework is due, but at the same time it is important to keep your feet wet and just like get to know people in industry. Plus the seminar speakers are typically selected as pretty good speakers. So make an effort to show up at the seminar. Other options where you have a chance to hear and connect with industry are on Wednesdays. SPE and AADE, the student organizations, typically have sort of free pizza and a talk by a company representative. So those are more industry-oriented because they're actually sponsored by industry. So more research-oriented ones are on Mondays and Wednesdays. Well, it's a free dinner if nothing. Free pizza is not to be discounted, but it's also you can actually keep in touch with what's going on in industry. So those are some networking suggestions. All right, so let's just briefly overview syllabus before we actually start with the course. So there are some rules, and you will find that pretty much in all classes that there are no makeups typically. Unless there is like really some sort of medical emergency or something that cannot be avoided, most of the time when the exam is scheduled. And the reason for that is that this is a large university. So actually scheduling a room is not an easy treat. If I miss scheduling this week, it's good luck. I cannot schedule a room that is large enough to fit this entire class. Just give you an example, this class I have to have for exam, I have to have double seating. So actually this room is not good as an exam room for this class. So if I'm going to compete for a larger room, I'm competing with the entire campus. And we're also all competing for the evening time when you can actually schedule something without conflict with other courses and so forth. So that's why the rules are relatively rigid. So midterm is already scheduled on Thursday, October 27th. It's scheduled at 6 o'clock, and I believe that time is already listed on syllabus. And midterm will weigh 35% of your grade. Final is also already scheduled by UT, and again, UT announces these schedules at the very beginning. Of the classes, because again, you need to have rooms that are large enough, and everybody is taking them at the same time. Also, there should be no overlaps, so that's not an easy task to actually schedule exams. So that is already scheduled for December 9th, 2 to 5 p.m. Homework and quizzes will take 10%. I will have approximately 8 to 10 homework sets. Most of them will be solutions of problems by hand, but there will be some that are actually computational tasks, most likely in MATLAB. Okay? And then quizzes will be unannounced here and there. I don't have a lot of quizzes, it's just kind of to help your retention of the material. So together they will actually take 10% of the grade. And the computer homework problems will actually be graded separately and count as a separate grade of 10%. So you can actually think of homework as altogether 20%. Okay? Homework should be turned in on time. I can typically, if homework is supposed to be submitted here in class, if you submit the same day, by the end of the day, you will still take the homework and it's going to be 10% off penalty. Okay? So whatever score you get, you're going to get 90% of it as a score. So that's still, I motivate you to submit homework no matter what, even if you're a little delayed, just make an effort to submit it, even if it's a little late. If you do have any problem because of which you cannot work on a homework, please come and talk to me, and the sooner the better. And again, I already mentioned the quizzes. Again, there will be not a lot of quizzes, but they're simply here to keep you a little bit on your toes and just check on the material. So they're not going to be hard. So those are typically simple questions that can be answered within 5 minutes. Now, all of the announcements and any kind of course materials, assignments, everything will be posted on Canvas. So by now, did everybody try to log into their Canvas account? So you will find things there. There is Files tab, and in that Files tab, I typically create a folder called Lectures, and that's where I put in course materials. So most of the notes, whatever it is that we have in class, will be posted. So don't worry about not being able to capture something. That plus recordings, plus the textbook, you should be good to go. YouTube channel is there. You could also, good news about my name is that it's ugly, but it's looking, but it's, if you know how to type it in, I'm the only one out there. So if you type it in correctly, there's no mistake. You find Masha Pradanovic, that's actually me. I have never encountered another one online. So the YouTube channel that is there is by me, and you will see, just watch, make sure if you sign up for the channel, please know that I'm teaching another class and both of them will be posted. So you will likely get notifications about both of those classes unless you actually specifically subscribe for this playlist. So I hope that can be adjusted. All right. So again, in terms of not being late, so there are good excuses and there are bad excuses. So you tell me, what is this example? Is that a good excuse or a bad excuse? That's pretty bad. Okay. I've heard a lot of excuses by now. So again, judge yourself. Look at your excuse and say, should I be excused? And then if you pass your own test, then that's a good excuse. Okay? So try to be. But again, things do happen in life, and there is no way around it. What am I missing? Run the bell. Okay. So the bell is not yet on the semester schedule, so I'm not sure why the bell needed there, and there's no semester. So again, things will get hard, especially if you're taking 3 courses or more. Be sure to manage your time. So as you progress in life, you probably have noticed, high school was this easy time where you could finish everything without any problem. Then came college, became a little more difficult to finish everything on time. And also there's all these social activities that started appearing that you could also participate in. Okay? And then comes graduate school, which is actually in that same progression. Suddenly, coursework is still okay. So coursework is still going to be assigned homework. We know it can be done. Your research, that's not the case. Okay? So your research is assigned with the best hope it can be done. Okay? And whether it can be done depends somewhat on you, somewhat on the problem itself. So you might actually discover that it's not doable. Okay? That's how it goes. And that's how most assignments work. So basically, as you progress in life, it's getting more and less, you're less and less able to project what's the time that it's going to take to solve the problem. So therefore, you have to become pretty good at time management. And again, at the same time, you have to manage your courses, and I am telling you, network is important, so you should make it to that graduate seminar if you only can. So there's a lot of events that it is important to make it to them, because people are social, and your contacts and who you know, where you go to, is basically your network where you can go for solution of the problem, whether you're in school or later at work. So you have to be judge of how to manage your time. So no matter what, there will be instances where you won't be able to complete something, and plus some life events inject themselves, you end up in a car accident, God forbid, or anything of that sort that basically throws in a wrench and makes it difficult for you to finish. So again, I'm open to good excuses, okay? And I will accommodate them as much as I can, but at the same time, just be mindful that yes, you will be stressed out and don't come up with lazy excuses, okay? So you can always study later, try to make up on your own, and it's not also the end of the world if you miss an assignment or two, even if it somewhat influences the grade. Okay. Again, if it's a serious case, it could be all kinds of reasons. Please let me know. Also, faculty don't talk to each other about courses. Okay? We have other things we talk about. But I don't check with Dr. Daigle when is he assigning his homework. I don't check with Dr. Stefanory when is he assigning his homework. He's always assigning homework, and it's always very long. Okay? So there's nothing to check there. So if it does happen that all three are due at one day, somebody please let me know. Okay? So we can work around that. Okay? So, and whatever it is, it's Dr. Stefanory's fault. His homeworks are too long. Just for the record. All right. Also, you will be tempted to, especially when pressed for time, to copy homework. Okay? Copies comes in various forms. Okay? You might, transport phenomena is a subject that is very well studied. A lot of problems are standard problems, and trust me, you can find solutions for them. Online, in textbooks, from other students, in all kinds of forms. But some problems are also so classic and come again and again that there's no way around for me. I have to assign them. Okay? I'm going to give you an example. Flow in a tube or flow in a slit. Most of the problems in transport phenomena in petroleum engineering come down in their simplified form to those two. Okay? So yes, I'm going to assign flow in a slit through a slit to you as a homework, and it's been assigned over and over, and it's solved in multiple places. Okay? So you can find a solution and copy it. What is that going to do to you in the exam? And you notice that exam is 35% and another one, final, is 45%. So 70% of your grade is exams. If you copy that solution for the homework, you're actually not going to improve your grade all that much. And at the same time, you rob yourself of actually solving the problem and understanding the problem. So even when you run into a wall, first run into that wall. First try to solve the problem on your own. Start thinking about it on your own. You know, go around roses. Attempt it one day, go back to it second day, and then go discuss with your peers. Okay? So the best is actually if you discuss with other people as a team, you will always be stronger and find solutions easier. Sometimes the moment you actually vocalize the question, the moment you form the question, solution actually appears to you. So learning is a process. It's not something, if somebody sitting next to you, it appears that they're suddenly like immediately solving things, that's probably because they thought about it already. Okay, it didn't magically appear, they're not, all of you are smart, so we have no issues there. Okay? So in that sense, understand that it's a process. And when the homework is assigned, first thing you do, you go and read it through. Just to kind of, you get over that initial shock. and then start thinking, and start actually thinking about it, and then maybe you will work on it next day or the day after. So don't copy verbatim. I have found copies, exact copies from the solutions that I posted. That's super light. So even if you look at somebody's solutions, or somebody actually works with you on the problem, or you work together, ultimately what you write down, the process of writing down, should be your solution. So even if you look at the solution, you should read through it, work through it, and then put it away and try to solve it yourself. That's how you prepare for the exam. And so whatever you turn in is then really your work, regardless of how you actually arrive at that solution. Also, in terms of things being turned in, Once you're turned into the Office of Students, that is on your record. So everybody who asks for your transcript will also get that. And if you're reported twice, you're out. So don't get there. Okay. All right, so in general, this university has this high achieving slogan, and petroleum engineering department is ranked number one. So we like to keep that high, and that doesn't come with copying and cheating. Okay. Okay. So whatever it is, prepare yourself for some hard work, but it will actually, the achievement will be that much greater once you're actually accomplished. All right. So in this class, transport phenomena is a part of the qualifying examination. I'm going to throw in a disclaimer immediately. So this prepares for you for the qualifying, but topics for the qualifying might actually not be all of it covered in this class. So sometimes it's a time juggle. So do expect that here and there is a topic that you might need to read on your own. You will actually get a list of topics for the class. We run into this often during the qualifying. Also, don't expect that everything is always verbatim. Some of the problems, so if you cover all of the topics that we go through in this class, and also possibly a couple of additional chapters that are there for qualifying, the qualifying problems, the problems in the qualifying exam, are still supposed to expose you to something that is possibly surprising or different than what was taught. You're not there to just basically copy what we learned in some chapter in transport. You're here to actually solve problems. And yes, sometimes they will sound like they're not always super aligned with the topics. Okay? That is expected. What we are testing in PhD qualifying is that if you're suddenly exposed to a new problem, can you figure out how to deal with it? Okay. So in that sense, do expect some surprises in the qualifying. That's not out of the line. That's how it works. Okay. And again, when working through homework, another motivation to work on it on your own is that exams are always slightly harder, if nothing, because they're timed. Okay? They will never be an identical copy of anything that was done in homework or in class, and qualifying exam is then a little harder. Okay. And this is not a course requirement, but I am posting a lot of electronic material, so try to not print as much as you can. Also, whatever it is that you do go through, like lots of papers or bottles you're using in class, please try to recycle. There's plenty of recycling bins all over the place. Okay? And think before you print anything. Finally, this is how I keep my sanity, especially in fall semester when I teach 2 classes. That is by running or walking. I will probably send an email today or tomorrow to the entire department inviting you to join a running group. It's a loosely associated running group. You can actually run on your own and never show up for any joint running, but still be part of the group. But we start about now preparing for half marathons and some people for full marathons. I typically run half marathons. I'm a slow runner, but I get there. I did 16 of them so far. So basically one of them here in Austin is in January, at the end of January, 3M half marathon, and then Austin half and full marathon is in February. You could do it either by running or walking. So the half marathon distance is 13.1 miles or 21 kilometers, and full is double that, so 26.2 miles or 42 kilometers. It can be done, surprisingly. If you actually start, even if you're not running right now, if you start training, the way the group works is we are training with Austin Fit organization. Austin is full of runners. If you're new to Austin, it's a very active. Austin is a very active city. So essentially on Saturdays at 7 a.m. you meet and you start enlarging the distance. So first time you run 2 miles, then you slowly start getting the distance larger and larger, and by February you can safely do either 13 or 26. Half marathon is actually a fun distance. You can actually do it without a problem. Full marathon is a major investment of time. So I would, if you've never done running, don't sign up for full immediately, you'll hurt yourself. No, maybe you will not, but it's not a safe thing to do. I think you should already build some running stamina and do a couple of half marathons first without doing full marathon. A lot of people do go, just sign up, suddenly start running, do a full marathon. I don't think that's healthy. Okay? They're proving whatever point to themselves or to some outside world, but for yourself, this is long distance running that is supposed to be with you for a long period of time. Don't kill your knees. All right, so if you need to know more, please email me. Again, whatever pace you might be, including walking. There is somebody in that group wasn't fit to accommodate it, so everybody's divided in pace groups, and there is a coach for each pace group. So I am, for instance, in 10 and a half to 11 minutes per mile group, so that's relatively slow. And I train with everybody else who is in that same distance, because you cannot run with somebody who is much faster than you or much slower than you for 2 hours. Okay? So essentially, then you will be split, so you are unlikely to run with me in the group. If you think that's going to help you in the grades, it will not. That's it. Just a suggestion. That's something that you might want to sign up for, because running after all or walking is relatively simple. You need sneakers and you get out. Okay. So let me know if you want to join. And this is, I don't even know from which year this is, but this is from year when a student from our department was 4th in a full marathon in Austin. He did it in 2 hours and 40 minutes. So. All right. Any questions on the rule? Okay. Any questions on the rules?
A quick question. So is there a syllabus for the transport qualifier, or is everything in the book for again?
No, there's actually a list of chapters that looks curiously similar to the one that is here on the syllabus, but it might have 1 or 2 additional. So everything in the book, that's a lot. That's probably 4 courses. Okay, so that's not everything. Okay. So, all right, any other questions? So before we move on, I'd like to meet you. I'm very bad with names, so you've been warned. It's gonna take me a moment to learn all your names, but I would also like you to meet everybody else. So if everybody would just stand up, say their name, and I don't know, something about yourself, some curious fact about yourself. Whatever you'd like to share. Would you like to start?
Hi everybody, I'm Sean, and I'm a second year master's student. I got my bachelor here at UT as well, and I'm about to graduate in December.
So any questions about Austin or UT? This is your Sean and your gun.
Hi everyone, I'm Lee. I'm from Pennsylvania.
Oh, that's curious.
My name is Pune. I'm from Iran. I just graduated from my master's in August.
All right. So she also knows quite a lot about the department. Okay.
My name is Javier, and I'm from Mexico, and I just got here. That's curious, you know?
So you need a group of people who are new to
New
Austin.
Miss.
Yeah.
Hi, my name is Adi. I'm from Indonesia.
Nice to meet you.
Hi, my name is Paul, first year PhD student from China.
Hi, my name is Tongyo. I'm also a first year PhD student from China.
Hello everyone, my name is Minyu. I'm also a first year PhD student. I'm from China.
So first year club.
I'm not a PhD student.
So actually that is curious. We have a person who's not a PhD. Are you intending to be PhD?
Yeah.
All right. it's curious to find anybody, so this class is typically taken by people who are just intending to take PhD qualifier at some point. So when I find somebody who's not, that's actually something special. Go ahead.
My name is Kai. I'm from China as well. I'm a first year PhD as well. Hi, everyone. My name is Wang. I come from China. I'm a new master student. This student from China also PhD supposed to be.
Yeah.
Hi, my name is Hamza. I'm from Iran, and I'm studying PhD student.
Hello, my name is Daria. I'm from Poland and I'm first year PhD student.
Her name I'll remember. My son's name is Dario.
Well, in sports, I'm a master's student, just graduated this year, and just started learning how to do ginger.
Hi, my name is Jane. I come from China too. I'm a first year PhD student. I did a master's degree in Canada. Yeah.
So how are you dealing with heat?
My hometown is almost there.
Oh, Canada, it's only Pennsylvania actually as well.
My name is Liu Guang, and I come from China too, and this is my first year.
Yeah, my name is Ni, and I come from Canada. I'm the first year PhD student, and I'm in master's school. Yeah.
So she has to do well.
Everyone, my name is Yun Liu. I come from China, and this is my first year as a PhD student.
Hey, everyone, my name is Judy. I transferred my PhD program from Canada to here, so it's gonna be like my starting off my 5th year here. So I hope I can graduate sometime in the next year.
Hi, my name is Abhishek. I'm originally from India. I just finished my master's in the spring, and it's my first year's PhD.
The veteran group again. You can go with questions.
Hi everyone, my name is Wendy Liu. It sounds quite like an English name, but actually it's spelled as W-E-N-D-I. It's not a Y-E-N. So, but it's quite easy to spell, quite easy to pronounce it for native English native speakers.
But when we pronounce it, is that actually close to what it should be? When I said Wendy, is that close?
Yes, it sounds quite close to, yes. And this is my first year in graduate school. I'm a master. I intend to take the qualifying exam. I come from China. Yes.
My name is Dave. I'm from Myanmar. I'm second year master's student.
Hi everyone, I'm Archana. I'm from India. I'm first year PhD student.
Hi, my name is Puneet, and I'm from India as well, and this is my first year PhD student. Hi everyone, I'm Bocha. I'm second year PhD student. I'm from China.
Hello, Gao. I graduated this summer and first year PhD student.
So I asked for curious facts, and this is as curious as we get this geography. All right.
So my name is Naomi, and I'm new master's student here, and I'm very excited to be here with Samuel.
There you go.
Hi everyone, I'm Valerie. I'm a second semester PhD student, so I started last semester. And I'm from Indonesia. I guess that's kind of interesting.
Actually, it's most interesting to be from the United States.
Yeah, hi guys, my name is Nikham. I'm Nigerian. I graduated in December with my master's. My bachelor's from UT. I might get a PhD but I get a job. I play soccer on there.
There we go. So anybody needs soccer instead of running for their keeping their sanity? Contact
Hey y'all, I'm Sharon. So I'm doing a PhD now apparently. There's a happy hour today organized by PGSA and Double Dave's for Varsity Pizza. All of you all should have gotten an email. So I hope you guys come. You can meet some of us veterans, I guess. And it's really cheap. You have to buy 3 beers to clear the credit card minimum, so it's a good deal.
It starts at 5.
And it's varsity, you said?
Yeah, double day.
Well, double days is if you've been.
No, it's varsity pizza. It used to be double days, but for all of you.
So the new students would know that, yeah.
I'm Lauren, I'm from right here in Central Texas, and I just graduated UT with a biochemistry degree. So I'm looking forward to starting on this.
So we have a Texan class, all right.
Hi, I'm Gurgej, and this is my second semester. I started in summer this year at my petroleum PhD, but my master's is in electrical engineering, and I did that back in 2013. And then I worked for 3 years, and I just decided to switch.
All right, well, welcome back to school.
Thank you.
Hello everyone, my name is Boyan. I work with a few people. Hi, I'm Pierre. I'm from France. I'm first year PhD.
Hey everyone, my name is Ryan. I'm working at the Lake, and I'm a second semester PhD student.
All right.
And I play a lot of guitar, and there's any musicians in class.
All right. So does anybody else want to advertise the activity?
I drink a lot of beer.
All right. Okay. So let's just go through some basic introduction. We will start today and finish it off, and then we will actual course material will probably start on Friday. So. Textbook you probably have around. This is a copy of an old version of the textbook. The newer version, this is the one I have. The newer version is red. There are also international. There's also an international version that might be actually cheaper to find. All of them are the same. Everything is fine. So it's not required in the sense that I'm not going to check whether you have purchased it, but we will use it a lot. So you can either borrow it from an older student. I shouldn't say out loud. So you can find it in all kinds of forms. Again, just get a book. We will use it a lot. It is a classic book. So this is the book that, when it came out in 1960, it basically transformed the way we teach transport phenomena it started in chemical engineering departments. In the way that it basically juxtaposes both momentum, mass, and heat transfer together and teaches them in one class.
So this book has everything that should be in the qualifying exam?
Yes, there is only one chapter that is basically on porous media. There I go and I amend it. But again, the class notes will be posted, so that should be fine. So this is your primary source of information. For some curious reason, this book is actually undergraduate text as well. It's too difficult, in my opinion, for undergraduates. It should be just fine for graduate level study. But again, it's comprehensive, and that's why it's been a classic for a while. Okay? So we will go through momentum transport, which is fluid mechanics, heat or energy transfer, and mass transfer. Most of the course and the bulk or the most difficult part of the course is momentum transfer, and we are starting with it. And then heat and mass will be relatively we will go through it in a speedy way because a lot of concepts are similar. So expect that near the end of semester we will kind of rush through heat and mass transfer. There's no way around it. It's a lot of material. And I do think it's the best if we focus, or the majority of the course focuses on the most difficult part, which is momentum transport. Some of you might have taken a transport class where you start with heat or mass transfer and then you go to momentum. And it's again because of the ease of material, but there's an expectation that as graduate students you have seen some of the material already, so it's not like completely new. And therefore I again focus on the majority of the course on momentum transport because it is the most difficult one. Okay? Motivation is obvious. Many petroleum engineering processes, they involve transport phenomena, and it's either heat, mass, or momentum, or all three. And you're transporting typically from one spatial location to another. Even without without petroleum engineering, we essentially exist thanks to transport phenomena. So you will find this type of class in most engineering branches or most sciences. So weather cycle is a transport phenomena, the way the landscape is formed, functioning of organs and tissues. They're all actually, all of those concepts at the core are the same. It's just that the applications that differ and essentially boundary conditions differ, which can throw in a wrench and can actually make two problems when you're solving them look completely different. I will give you examples. So if you're transporting fluid in pipes in petroleum, those pipes are rigid, they're not changing, right? So you just have these pipes and you have ball boundary condition that is relatively simple. Now if you're going to a living tissue, and if you think about arteries, which are pipes, but arteries change. They pulse with your blood. So your boundary condition, you have basically a moving boundary and you have fluid-solid exchange, which becomes much more complex to actually model because your fluid can move that boundary, so you have both solid and fluid mechanics combined. It's coupled. It's always coupled, but in some cases it's more dominant than the others. So then suddenly all of the solutions to actually solve the problems start differing in the sense because of that boundary condition is actually throwing in a lot of difference. But in essence, the transport through those has a lot of similarities in both cases. Okay? So our society functions thanks to oil and natural gas, even though it's not always, I don't think that petroleum engineers are always given thanks for that. We want transportation, getting to school, getting to work, having things in the grocery store, even in a more basic level, if you want farmers to produce, they typically need machinery. So oil provides fuel for transportation. We also want electricity, and quite a bit of it actually comes from natural gas. So we want also plastics. Plastics, of course, are byproducts of petroleum. Okay? So this is actually the picture of all of the items in a typical American household that actually come from petroleum. So most of it is plastics, but of course a lot of materials that involve, they're involved in shoes, siding of the house, and so forth come from petroleum as well. So if you need energy related, so this course will not focus on statistics, but often if you actually need to justify your research or for any kind of information that is driving policies in countries, and those are important, the U.S. Energy Information Administration has an annual review that is a pretty good and extensive source of information. Most of companies, if you go to companies like BP or Exxon or Shell or larger companies, will also have their own annual reviews and projections for the next 5 to 10 years. So those are actually good sources. So it's just to know where to go. So again, BP is an example here. So they have an energy outlook issued every year. So those are good trends to monitor because that, of course, affects your job situation. So we have some students here who are in PhD, even though they maybe didn't want to. But we're very happy to have you. So then energy consumption by fuel type, if you go to, so this is one typical graph from the Energy Administration. You can see that we're still on the order of 40% of energy. It comes from petroleum and other liquids. Then natural gas is another almost 30%, and then we have coal, nuclear, liquid, and renewables. So as much as in terms of policies, you will see a lot of renewables. They are there, and they're part of the equation, but by no means they can actually replace the current society need for energy. So petroleum and oil and gas are there to stay for quite a while. This is another way to see that, so you can actually see in terms of the source of energy where it's actually used. So if we monitor petroleum here, it's basically 26% goes towards transportation and about 9% towards industrial uses. If you go to natural gas, then you can see that it's going there to industrial, commercial, and residential uses, as well as electricity generation. Okay. So one key observation is that our society functions in large part thanks to oil and natural gas, and consequence of it is that the global economy is essentially built on oil and gas business. Now, second type of observation is that there is no oil and gas without fluid flow, which is where you have to suffer through this class. And finally, motion flux occurs whenever there is a gradient of potential, and this is the key technical part that we will reinforce in transport, and it is there for any type of transport, and I would say that it works in economics as well. So in terms of being practical, let's just see how much oil do we actually have to transport around. So what is the approximate, does anybody know what is the approximate world crude oil production? And I'm actually having this old information from 2014, but it hasn't gone too far from it. A million oil barrels per day? That's pretty good. Any other guesses? 58? It's actually closer to 90. So I think now it's about 87 to 90, but the information I have from 2014 is about 80. So this is also a quick note that a lot of U.S. industry is working in barrels. So if you are used to liters, you have to start converting things to gallons and barrels, and it can be a little annoying, but it's necessary. So you essentially have to operate in both metric system and the so-called British system. And we will in this course kind of go back and forth, okay? Because that's what's used in industry, okay? So this is also the production in thousands of barrels per day. So I think this is for major producers, so the top 5. What is OPEC? Certain terms you need to know.
Organization of Petroleum Exporting Countries.
Organization of Petroleum Exporting Countries. Which countries are in OPEC? Saudi Arabia. Let's go in Middle East. Who in Middle East? Iran, Iraq, Kuwait, UAE in Middle East. UAE and Qatar in Middle East. Then Venezuela, and which other country in South America? Ecuador. Venezuela and Ecuador, and then also in Africa. Nigeria, Angola, Libya, and one more. Algeria, I think. No, China is not. It's not in Africa. And that's it, actually. So U.S. is not there, but again, U.S., Russia, and China and Canada are nevertheless the major producers. So about I did calculation for 78 million barrels of oil. And actually, if you do a calculation, it's about filling 2.5 of a large swim. This is a large swimming pool. This is the Olympic swimming pool in Austin. It's in Jamal Swimming Center. So you need to fill 2.5 of these every minute, essentially, to come up with the oil production per day. So that's a lot of oil to flow around. Okay? Now, the problem we're having in terms of economic gradients or geopolitical gradients is that those that consume oil are not necessarily, or that consume the oil the most, are not necessarily those that produce the oil the most or export the oil the most. So that creates for some fun competition in the world. That is essentially the reason for the current price slump. So that's essentially all that I'm going to say about this class, because that's not what we're analyzing here, but we have to be very well aware of it. And I think I'm over the time. So this is where I'm going to stop and we're gonna continue. I see you on Friday.